Thanks, Rich.
You're welcome. Well, I thank you for the opportunity to talk to you today. Not only have I been in the RubyMotion community for a long time, I think I was the first one to actually see the output, other than Laurent, to see the output of the first line of text, the hello world, on the simulator screen when he got it working. But I've been in the Ruby community for a very long time, since about 2000. I helped start Ruby Central and run all the Ruby and Rails conferences for a very long time until I said that was too much and enough. So sorry, Laurent, for having to schedule conferences. It's actually a very time-consuming and painful process, but he's doing a great job. So you're doing a great job. This is my first conference I've been to in I think 2 years, and I was going to like 5 or 6 a year. So you get a little like withdrawal. So this is actually great to come back. I've been building my company CargoSense, and before this I was at Living Social. I ran the R&D group there, and because my consultancy was bought by Living Social. But I left Living Social because they raised $1.1 billion in private equity, and they still aren't profitable. And that's just not a company I want to be part of. So I'm building CargoSense, and today I'm going to talk about CargoSense a little bit, introduce you what I'm doing with this, and specifically how we use RubyMotion, obviously. So I'm going to talk about cargo and the shipment of things. But when I left Living Social at the end of 2012, early 2013, I was working with a gentleman who'd been trying to monitor trucks during shipment. So a refrigerated truck, as it's moving things, he wanted to make sure that those trucks were staying in the temperatures that they were supposed to be staying in. And he had this box that they built, this like 2-foot cube that they were going to install on a truck that was basically an embedded computer and these proprietary sensors. And I said, I think we can do the entire thing with an iPad mini and Bluetooth sensors and use like the 3G on the iPad, and it's going to be great. So we were going to do everything in software, and we did all this in RubyMotion starting from the beginning. So what do we do? So CargoSense, what we do is we help manufacturers of products make sure their products get to their customers in the condition that they manufactured them in. And if we could beam them there, that would be awesome. So that's next, okay? You do the whole JIT injection stuff and then beaming, because you can make a lot of money at this. But we don't do that. Instead, what we do is we package our stuff and we move it through a very complex, this is called a logistics network. A logistics network is trucks to warehouses to airlines to warehouses to trucks to warehouses and then eventually out to the customer where it's unboxed and they look at this stuff. In some industries like pharmaceuticals, food, and electronics, these things are really susceptible to the environment. And so what we did is, so in things like pharmaceuticals, they add these environmental sensors. And I'll show you, I've got so many little devices. So we work with a lot of hardware, which is actually what makes this kind of cool. Is a little sensor. You put the sensor inside there. It records all this environmental information. They check it on the other side to make sure the thing's good, like temperature, right? So they measure the temperature, especially of pharmaceutical products. So in our company, we wrap this process with a SaaS. Everything back there is built, the domain modeling is built actually in Rails. It's a pure API. And then we have all the data ingestion and the stuff we're doing is in Elixir, so on Erlang. So on the back end, it's basically pure APIs, and then we have these apps that we build on the front end that talk to those APIs, web apps, as well as mobile apps using RubyMotion. And so, we have these sensors that are coming through. We also instrument warehouses, so we can measure the temperature inside of warehouses. We make sure it all stays good, and we let them know whether their product's good or dead. So that's kind of what we do. We're doing some other neat stuff with Bluetooth that we've actually patented. And then lastly, we're using iBeacons. So this is an iBeacon. Anyone played with iBeacons? They're pretty cool, right? So what we're doing with iBeacons is very much not what Apple's doing with iBeacons, which is when your phone, you walk into a room that has an iBeacon in it, your phone can wake up and say, I'm in this room. But it's neat because what it can do is you can register an app that says, I want to know when I'm around a beacon of the serial number, and your phone will wake your app up. And that's really great. So your app's not on, but your app gets woken up and you can do things. What we're doing is, this is a Bluetooth sensor. So it's sensing the environment. It's also waking up about every 5 minutes and doing a scan for iBeacons. So it actually records the iBeacons it's near. So if you have an iBeacon in a truck, by the way, these things can be like $10, or actually even less in volumes, like $5. So trucking companies can put a beacon in there once, lasts like 5 years on like 4 AA batteries for like the bigger beacons, and then the cargo can remember where it's been. So it's like way cheaper than GPS. It's super cheap. As a matter of fact, we're talking to UPS about putting them in all their trucks, 100,000 of them, 350 planes. And UPS is like, this is the rounding error. It's like $500,000 for them to instrument all their trucks. And they just change batteries once every 5 years. But it gives you location. It gives you actually not location, it gives you proximity. So we call it proximity. And we're building a service for this called logistics beacons, which again is not retail beacons, which is what Apple does with it. But that's basically what CargoSense does. We're building all of this stuff, but it's really at these apps that we're going to focus on today. A little bit about the pharmaceutical market. Pharmaceutical market loses $35 billion a year in pharmaceutical products that go because they cut too hot or too cold, mostly too hot, when they're being transported. So when I say lose, they're damaged, they're destroyed due to temperature. 35 billion is lost. So I just want like 10% of that. That's it. But what we're doing is we're trying to optimize this process. 80 million shipments. A shipment is composed of n number of pallets of n number of goods. So you're talking about probably somewhere around 1 billion cartons or boxes of pharmaceutical products are moved a year, vaccines and everything else. EU updated its good distribution practice to mandate that they actually have to ensure that temperature conditions are maintained, so there's good regulatory pressure. And this is our system that we've built. You configure these little sensors at the point of origin. They record during shipment. You take them out and you read them on the other side, and then you analyze the data and everything else. And we're using RubyMotion here to build. Wow, that moved. That was weird. I thought this was anyway. So we're using RubyMotion here to configure the sensors, and in some instances using it here to read. Actually, we built an OS 10 app with RubyMotion to do the reading for the customer that we have in Switzerland. This is our application stack. It's so simple. Here is our challenge, right? Here's our services. And these services, like I said, these are Elixir services, and this is a Rails service. We can integrate third-party APIs. But we need to be able to run on native desktop operating systems. So you've got to be able to integrate with USB connected. So this thing as a USB connector so you can read data. You can't really use a web app to read data off a USB drive, thankfully, right? But we've got a stack that we've built on the web based on Ember. So if anyone uses Ember or an MVC architecture here on the web. So we've built an entire application stack on JavaScript on Ember, and we've got our core stuff that wraps our services. And then down here, it sits on top of course, we can run the stuff cross-browser. We can also sit on Chromium and Node, which is or io.js, but effectively is Electron, which is what Microsoft used. This is what Atom Shell. It's what Microsoft used to build Microsoft Code, which is their cross-platform editor. So we're using this to be able to get us apps that can run on OS 10, Windows, Linux. Not that any pharma uses Linux, just so you know. But they do use a lot of Windows. And so unfortunately, but we do integrate with the things here natively, and that's for the desktop. Now, on the mobile side, our strategy is, and here, by the way, you get automatic updates, you get crash reporting. So you get automatic crash reporting and platform native installers, which is great. But on this side, which is where we're all interested in, we need to be able to target, iOS, Android, maybe future, if any other vendor, maybe Research Motion. Have you looked at BlackBerry? No. But anyway, so we had our cross-platform here, and we have, we use RubyMotion for that, and then, of course, gems that the community builds, which we love. We have our own gems that we write internally that wrap our services, and then this thing called CocoMotion, which I'm going to talk about today. And so CocoMotion is my UI framework that I built to be able to build our apps. So this is an open source. If you guys want another UI framework that's open source, I'll open source it. So I'll just let you know. If you don't, that's fine, because you want to fragment the community. Now that I'm going to tell you, no, I'm kidding. But what we do with this, and it's interesting, we build role-specific apps. So instead of building big, complex apps, we build a lot of little, simple apps. So we have apps for somebody shipping, apps for somebody receiving data, apps where somebody's sitting there with a barcode and they're shipping just, like they're configuring 30 sensors to go on 30 pallets, and it has to be done in a minute, like literally 1 minute. And we were building our app on iOS. We kept optimizing it with the customer, and the app is basically this. I mean, I can run it in the simulator as well, but you go and you configure a shipment, and you have to select some things, and then you scan for sensors, the Bluetooth sensors, and you read the serial number, because what you're trying to do is say, this sensor's in this box, and this sensor's in this box, and you're doing this process. So in the beginning, we did this. It's just like, I think per box, it was taking us like a minute. We got it down to where it was 5 seconds a box. It was awesome. So because you're thinking everything is in production and high, high velocity here in these manufacturing plants. We have one customer that's using us right now on one lane. They ship 300 boxes a month. So that day that they ship or they configure those 300 boxes, they've got to use our system. And the less time it takes, the better. They ship 10,000 boxes a month. Now what's great is we get paid per shipment. So we make transactional revenue, which is the way to go. I mean, the subscription revenue is fine. Transactional revenue is great. Can you imagine every time somebody compiled RubyMotion, you got paid? That would, yeah, I know. It was actually pretty good. And then we have the ability of actually reading data off Bluetooth Low Energy sensors too. But the reason there's a USB port on there is this is really slow over Bluetooth Low Energy. You move 4 meg of data over like basically 120 kilobits a second, it's slow. So we almost always use USB to read it. And that's actually where RubyMotion on OS 10 came in. So we were pulling data off sensors very fast with RubyMotion on OS 10. So we built an app. I built an app in like 3 days. And we shared all the networking code, actually the whole API system, because it was on AF networking. That's what we were using for communication at the time. So we ported the thing that talked to our service in like an hour. It totally worked. There were a couple things we had to change. But to be able to reuse that entire code base, and then we just built the UI. And we just built an OS 10 UI on top of it. But it was like 4 days, and we had an app in production. It's been used for 7 months, and it's never broken. I mean, it's great. I just tell them to shut it off every time and then start it back up. So I don't know about memory leaks or anything like that, but that's just not what we do. So what I want to do is I want to talk about the framework that we built, which is CocoMotion. And I like to have songs. So anyone remember a framework called Hot Cocoa? Yeah? Hot Cocoa, Hot Cocoa. Remember that song? It was like a really cool, catchy little song that we used for it. And I was going to say, come on, baby, do the CocoMotion. Because it kind of... Anyway, when Laurent actually was starting the process of creating RubyMotion, I started this. Because I knew he was doing it. So I'm like, I'm going to build a UI framework. And I never released it. But what I wanted to do was build something to help me build UIs faster, right? So this is what we wanted to do. So why? Why did I do this? Because there's certain painful things about iOS UI development. For one thing, I hate visual builders. Hate them. I want to be able to see in code what is happening. The idea of interface builder to me is magic. Now I do a lot of Rails development too. I help build some of the stuff that's underneath Rails, and there's a lot of magic that happens there. I mean, you're writing code and things happen, but when interface builder lays things out, you have no idea why, and having to go through, you have to really understand how to go through the UI to figure out what's going on with interface builder. So we want to be able to do these things from the command line. The 3 things I see as an issue here are, 1, configuring UIKit components. So a UIKit component, right? Some subclass of UI view, they have a huge number of methods, huge number of settings. And so if you've ever seen, classic Objective-C code, when folks are configuring buttons, they usually have this file of Objective-C code that says, this is my standard button. And that file has like 20 lines of code in it. And they have all these parameters that you can pass into that thing to create a button for themselves. So they build their own generators. And they do it, and they have that file. It's like some util file or something, or UI util, which generates hundreds of component types. And they rewrite, and then they move that thing around and cargo cult it, right? Because all of our apps have to look the same, and so we do this. And that sucks. The second thing is styling components, right? How do we style our components to make them look the way we want them to do very quickly? And lastly, how do we lay them out? So it's one thing when you're an interface builder and you can drag things around. It's nice. I actually went, I was in south of France here earlier in the week, and they were using Delphi. So Delphi can statically build native iOS and Android applications. And so they have a visual builder. They're like building the thing, and they're just like, and they were bringing it up, and there's all these lines in between everything, and I'm like, what's that? This is how the logic's connected, and I'm just like, this is just out of control. But you can visually lay things out, but programmatically laying them out is actually harder, right? Especially when a designer gives you a design and goes, this image, it needs to be appearing on the iPad like that. You deviate from that, I'll kill you. So you want to be able to lay out your components exactly that way, the way folks want to do it. So these are the 3 things I was trying to solve. Now, how did I go about this? And the way I went about this is in Hot Cocoa, we added a notion of builders as well. But what you did in Hot Cocoa, and Hot Cocoa was, by the way, on Mac Ruby, which is the kind of the progenitor, if you will, of RubyMotion. Some early thinking went on there. That was on OS 10. What the builders were in Hot Cocoa is they're generators. They would generate, say, a UI button. Well, there it was an NS button, right? Because it was a Netscape button. Or not Netscape, sorry. Next Step. Gosh, that's an OpenStep. No. But yeah, a Next Step button. But they would generate those things, but it would adorn it. In other words, I wanted it to feel like a Ruby class. And so it mixed in modules. Now, when you take an NS button class on, well, even on today, RubyMotion, and you extend that object with Ruby, right? So you mix it into the instance of that object. The superclass changes because you're injecting the, what do they call the darn thing? The singleton class. Yeah, so the singleton class gets shoved into the class hierarchy, and so it's like it's a subclass now of, say, UI button. And some things freak out, like when you do that. So that was a bad idea. So I wanted a builder to generate me a UI button. Unadorned, just configure the darn thing. That's it. So builders do that. Matter of fact, what I wanted it to do is build a real component, be able to rebuild that existing component. So I've got a component. I want to be able to easily build it with a nice syntax, and then I want to be able to reapply that, maybe adjust some of the styles and reapply it to there. I want to inherit so that it follows the inheritance hierarchy. And this is all going to sound awfully familiar to Red Potion or RMQ. It's RMQ because you want to be able to say, the builder for a button subclass is the builder for a control, which subclass is the builder for a view, because that follows the hierarchy of UI button, UI control, and UI view. You want to be able to do something about constants because constants are ridiculous. Very long, because a constant in C is a global namespace. So the reason constants are so long on iOS is it's in a global namespace. You have no encapsulation. It's one big flat namespace. So you have very long constant names. So I wanted to do something about that. Smart defaults, so you could have defaults, for things. Those things I'll talk about. Options and properties. So, property is basically something you can get and set, where an option is something you might be able to pass in and configure it. And then also support a custom class, so a subclass of UI button. If you created a subclass of a UI button, I wanted a builder to be able to work with that subclass. And so you didn't have to create your own builder for your special one. And then lastly, I wanted to be able to inject some documentation and type parameters in there so that I could be intelligent about how the builder takes the options you're passing into it and then validates that those options are right and outputs something if they're wrong. So I hope people can read this. Because it's an image, so it's nothing I can really do if it's not. But this is a builder for an activity indicator. It's just a small one. That's why I grabbed it. So what you do here is, and it's got a little DSL in the builder in the sense that you have methods. So I'll call it a DSL. They're just methods without parentheses. So we call them a DSL. So I do option style, and it's a constant. And the documentation is this, which I, by the way, copy and pasted. So Apple someday will chase me down on whatever. And it's got a default of white, right, which is hash. And these go all the way down to a constant. So I built this idea of a constant map, which is underneath a particular builder, you've got constants that fall under that. Like style can be white or gray or large. Instead of having UI activity indicator view style white, you just say style white like that. You would just say style : white when you pass the option in. And what's nice is this is really namespaced because this actually only has to do with an activity indicator. These constants are only that. You know, there's some, like UI control has a ton of constants. It has like 8 sets of constants, and I map all of them. And because it inherits, well, I'll go through and point out these things. First, we have options. Option, you style. And if you notice down here, it says self-component. You allocate this thing, and then you init it with a style, because that's how you build an activity indicator. You actually initialize an activity indicator with its style, so it pulls it out of the options hash. Because I define these options and properties, and again, the idea of a property is when you define something as a property, it sets that thing if you pass it in automatically. You don't have to do it down here explicitly. So any builder that subclasses from, you know, the builder stuff will inherit the ability of actually having properties applied to it that you pass in. In addition, all these things are used to validate what you pass in. So if you pass in options that it doesn't recognize, like if you mistype a hash key, it will say, I don't know what that is. Right? So it validates, it uses this to validate the parameters. And the reason I put the documentation in there is I have this grand plan of generating documentation, which is what I will do if I open source this and anyone else wants to use it. But, so we have properties. We have the type, again, documentation. I wanted to be able to use it for documentation purposes. The documentation itself, the defaults, which I talked about. Inheritance, so this is where, this is going from the view builder. Right, so the view builder, you have the activity indicator builder. And then lastly, custom classes. So if you notice this says, it doesn't say UI activity indicator view dot alloc. It says alloc, which is a method, that class. So inside that method, it says if you pass the class, the class hash key with your own class, override it. Otherwise, that's your default. So it makes it very easy to be able to say, you would look at this code, you know what it's going to allocate by default, but you could override it with your own subclass of that. And this is how you use it. So in a class, you can just include the view controller behaviors. This gives you the methods, which I'll show you here in a sec. It can be a mix-in. You can actually inherit, but I hate inheriting because it limits you, right? I don't like to inherit from anything but the standard UI view controllers. I'm not trying to change the way we build view controllers. So if you wanted to inherit from a table view controller, you can totally do that and just mix this in. So this mix-in gives you a set of methods, one of which is build. So in your view did load, you just say I want to build a button. So this is the single build method. There's one. I didn't want to do a thing where it said, oh, you did method missing and I found this thing and it happens to be a builder. Like, so you could just say button, whatever. I don't mind having one more name here, like build, and it's explicit. I want to build a button called new shipment. Now, that's the type, the button, and it goes and it looks up the builders based on that. This is something I just came to is actually really helpful. New shipment underscore button, so name underscore type, gets created as an instance variable inside this object when you call this method. You don't have to do anything, but you need to hold on to the object. So that's automatically built for you right up front. Then you have a title, new shipment, target, action, right? So it's target action. These are the things these are actually from control, but this is the title for that button. You can actually, it's very powerful. You can actually pass in here the titles for, so if you pass a hash to title, you can do titles for different states. So this is actually much more powerful than what I show here, but by default it does that. And I won't talk about those things down below right now. So the current builders I have are these. So they wrap basically all the stuff I've ever had to use in UIKit. There's also helpers. So the difference between a builder and a helper is kind of like a key thing, and things like the navigation helper help you deal with the navigation controller, which can be kind of a pain. Alert helper lets you deal with alerts and things like that. So these helpers are used in addition to these builders to really simplify your code. This is an example of a nav helper. So inside your viewDidLoad load method, you just say nav. That's the method. That's what the navigation helper gives you. So you can just say nav, and you can do a title, and you can say the left button, title back, action. Oh, I love that. Like stabby proc, right? So nav, and you can do a nav pop. So that's a really nice little concise code. You can also do target action here. So what it does is if you're calling this method, and by the way, that uses a builder. So there's a navigation controller builder. If target isn't passed, it takes self as target. If action is basically a proc, then it actually sets the target to be that proc, and it sets the action to be call. Right? So that's how that works, which is pretty nice. But if you're doing something simple, you can just do it in line. Otherwise, you can do target action and call a method down here. You don't even have to do target. You can just do action. It'll call a method if it's a string, a selector. Alert. So you can say alert. I want this title. I can have buttons. So this pops up multiple buttons on my alert. I have different styles that I've created, like login password. You know, it's like you want the login password thing. I even added the ability of doing the keyboard type because it was annoying. Like, you know, when you type in the username and the password, if you want to control what that text field is, like it's an email, the username is an email, I built the ability of it's to select what kind of keyboard you had. So that when you do this, that login is an email. And then you get called back when somebody clicks on a button, and you actually get the helper object back. So if the button is login, so it's really easy to see. I do this, I have 2 buttons. If the button is login, validate your credentials, you're going to do whatever. And notice helper.login, helper.password, so you get the data back from the helper. And you know, there's just standard, you can just say alert, title, whatever, and it'll pop up an alert. Like you don't need to pass a block or anything else if you just want to do that. It's very simple. This is just a more complete example. And if you notice here, the @login_button.update. So remember how I said early on that I wanted to be able to take and build something, so like a button, I wanted to build a button, and then update it later? Like here I want to update whether it's enabled or not. Because what happens when a person tries to log in, it disables a button. And then when it validates or not, it comes back and it re-enables the button if it fails. And I want to change the background color back to the button color. We'll talk about colors in a second and themes. But I want to change the color. So it grays out, and then it turns back to the normal color if you fail. And so this is a little bit magic, the way I do this. But effectively what I do is when you build a builder, when a builder builds a component, it stores itself as an instance variable on that UI view. So it literally injects itself as an instance variable on, say, the button. The builder that built that button is an instance variable on that button. So that when you call update, the update method, which is actually on kernel, I know it's terrible, but anyway, the update method is on kernel, but it just says, do I have an instance variable called this thing? If I do, I will use the original set of options you passed to build that button. I'll merge these things in, and then I'll update the button. So if you have a whole bunch of defaults that you did in your button, this is just overriding those things. So you can, and I just figured update bang probably wouldn't be something you would run into normally on iOS, so that's why I chose that. So that's just an example of using helpers. Styling components. So we want to make components, we want to style them. I went through a lot of things to try and do this. I started, by the way, with, oh gosh, what is the thing? Pixate? The app was really slow. So what I did is I built a theme. And so the theme lets you do fonts with inheritance and sizes, right? Because you want, so this is kind of pattern after CSS, like all things are. Color, you want to do hex, you want to do opacity, dark, and lighten. So anyone who's doing anything in CSS, you know, they're going to come with their SAS stuff, and they're going to be like, I want to darken and lighten this color because this is the only way I think about this. Like I don't know what the RGB values are. Don't make me compute that. So you wanted to be able to darken and lighten. With styling, you want to style by component type. Like, what do all my buttons look like? And then be able to say, and I want to have a named style for a certain type of button. So here's what we got for fonts. So I can have a base font. So you can give it a family, and then I have methods inside the theme, like iPad ? Well, it's just you set default sizes based on the actual size of the thing. And I know that this is terribly wrong in iOS 9. I was told this yesterday that in iOS 9 you can't actually ask for iPad or not. You have to ask for like large, medium, or small, or whatever the new nomenclature is to represent the kind of devices you're on. But right now you can say, is it an iPad? If it is, I want to be an 18-point font. Otherwise, the default is going to be a 12-point font. So this lets you set up all of your fonts of name, and then you have these that subclass that and override the size. So you've got button bold, the bold one, and so it just lets you build up a set of fonts with names. and you could subclass base fonts, so you can have your family defined up top, and then have all your custom, named fonts down below for buttons and the like. Colors. So we can have colors. You can just pass in hex. Nice. You can actually, by the way, you can pass in just a UI color. So you can just pass in a UI color instance if you want. You can actually say then transparent clouds opacifies clouds 75%. So it's really simple. You can lighten sunflower 30%. You can tell we're using the, anyone who does design, these are the flat UI colors. But so we have transparent clouds, we have the highlighter, so you can lighten, darken, and you build this up. So you've got all of your named colors. So this is how styles work for components. Everything you can use in a builder to build that thing can be a style. So my style for all buttons in my system have the title color of white, have the font color of the font called button, remember we defined that before, have a background color of the color of button, which we defined before, and then a corner radius of 4, a tint color of the color white. And so it lets you define what all buttons look like, but the danger button has a background color that's red. Right, so you can have named things as well as default. So this is a default, this is a named thing, this is a named thing. Like this one is multi-line, big font, based on what size you're on. So this lets you style component types and then specific component instances, if you will. And how this is used is you say style class. Now you don't have to do that if you just want a button because it is a button. So it'll take all the button stuff, but it lets you have a style class for home button. And the other thing you can do with the style is you can basically have it not style from that base. So you can kind of override the base and say, I don't want it to be that. Lastly, laying out components. This is where all hell breaks loose. Everyone kind of agrees to there's different ways of configuring components. There's different ways of styling components. Laying out components is like hell. So here's what we did, or what I did. I speak of we. It's kind of weird. Auto layout. I call it auto layout now. I used to call it layout until 3 days ago when Mark told me I should be using auto layout. And he sent me the auto layout documentation. And so on the train ride down to the south of France, I switched my own constraint solver, which I built prior to auto layout existing on iOS. I built a constraint solver to use the constraint solver, which is auto layout, which is built in, right? Which is cool. And on the way down, I did it, and on the way back, I wrote slides. So it works. So you can do one of two things. So I've chosen to be very picky about what I allow you to do with my constraint solver. You can either constrain yourself inside your view, your super view, right? So I am going to have a component. It's going to be placed in a super view. I'm going to constrain myself inside that super view, or you can constrain yourself to a sibling. I have a component here, I have a component here, I want to constrain it so it moves with it. That's the only two things I allow you to do. I don't allow you to say, I'm going to constrain myself this way to my parent super view, and I'm going to constrain myself this way to this other component. You can do that with auto layout. I just don't make it easy, because I think that's the way of madness. Now you can do it, but it gets really hard. I also don't do anything with multipliers, so you can have like multipliers in auto layout, where you can say, I want this thing to be 2x that, and I don't do that. I just don't. And you can just ignore my layout system if you don't want it. So this is the way layouts, and just trying to explain this was kind of hard, but basically when you put a view inside of its super view, when you specify the left, what you're saying is, I want the left side of this to be this far away from this wall, right? This is my parent. Or I want the right side of this component to be this far away from the right. So what you're, anyone remember springs and struts? It's old school programming on Next Step. I said it right that time. I had to think. But what you do is this is basically like setting up a connector between the right side of this component and this side. So you can see that if you set a left and a right, if the parent view got bigger, this thing would expand because it's anchored to both sides. And you can do the same with top and bottom. Now, you can also do width and height. The key to this is you can do two things vertically or two things horizontally. In other words, you can't constrain left and right and width because it just won't work. You got too many things pulling on each other, right? You would literally shatter the view. It would rip the side of the view apart, and it would explode on your... No, it wouldn't. But it just... And actually, what's nice about the auto layout is it will tell you that that's a problem. It'll say that you can't do it. But in my system, I actually check and say, if you're specifying left and right, you can't do width. You just can't. And I want somebody to know that because they seem to be wanting to do a thing, and I don't know what they're trying to do. But you can't specify 3 vertically and 3 horizontally. So you could do bottom and height, in which case this thing is going to be a certain height and width and be anchored over here. Or you can say, I want to anchor it up here, and I want it to be a certain height and width. Or you can say, I want it to be, expand horizontally, but be a certain height and anchored to the top. So by the way, I do that a lot for text. So when I'm trying to build like a label, I go left 0, right 0, top 10, center the text. So my label literally is the width of, say, an iPhone or an iPad. But you know what's great? It's perfectly centered. And I didn't have to compute that. And nor do you really want to. So it's longer than it needs to be, but you don't see that. And it's just a label, so it doesn't really matter. So that is how you anchor to your super view. It's a very common thing to do. Less common to me is... so these are examples. I'm sorry, it's down below. But of things you could do. I just explained them. What you can't do here is like left, right, 10, 10, 10, and then the width is 10 because it won't fit. I mean, you can't do all 3 of those things. So anchoring or constraining yourself to a sibling view, you can say, I want my view to be right of this view. So you can say, I want you to be right of that view. Or you can say, I want it to be left of this view. And I also want it to be below this view or above this view. And you can give offsets, and there's default offsets, which follows the iOS human interface guidelines for how far you should separate things by default. But each one of these things allow you to be, I want to be above another component, so this view would follow that thing. It's above. Now, you can also do width and height, so you can set the width and height of your view. You can then align. So when you do this, and I say I want to anchor myself to that other thing, you can say I want to align the bottoms, I want to align the tops, I want to align right or left, I want to align center. So that centers the components. And of course, you can do center this way too. So if you can actually say, I want to be right of, and I want to align center, or right of, sorry. I want to align center, this would actually be set here, and it would be centered on that. So that's kind of the way you constrain yourself to a sibling view. Obviously, you wouldn't be doing all these things at once. This is like, usually it's, I want to line 3 things up. It's very easy. I'm going to build this. I'm going to this one to be right of that. And I want this one to be right of that. And so that's the way that works. It's very, very simple. So this is it in use. And sorry, it's getting kind of smaller. But basically, device orientation specific. So when we lay out a section of code, this is kind of a nice thing I did in my builder. The builder is aware of the device you're on. So you can build these are really just hashes. They aren't blocks, right? They're just hashes. You can build hashes that are device specific. As a matter of fact, you can have different sets that are even more specific. iPhone will take any iPhone. iPhone landscape will be any landscape orientation. iPhone portrait, any portrait orientation. And those sets will only be applied if the device is in that orientation. So normally, like the app here I'm showing is only in portrait orientation because we use the camera to do barcode scanning, so it always has to be up. So we lock portrait vertically. So this is not that complex. But I just say the layout, the width, and the height, and the left and the top. So, left, top, width, height. I have a button. Then I have this other button here, and the layout is right of that button, right? This new shipment button. This is where the instance variable came in because I want to reference the button I just created. And with the width and height and the offset of it of 45 pixels. But on the iPhone, if you notice here on the iPhone, I've got a width, height, left, top. But down here, I have the iPhone layout below that one. So on the iPhone, it stacks the buttons. On the iPad, they're horizontal. So it's nice. It's right here, I can see exactly how these buttons relate to each other. And, it's easy for me. So I don't separate out configuration and layout or anything else like that. I just have this in the view did load, define my components, and that's it. So it's super easy for me. So there's your layout. There's your relative layout. So that is really why I built what I built. And I can show you our application that we built in this. I mean, that's the end of the actual official presentation. So I'm going to go ahead and run the app here. So this is just our iOS app that we use for configuring our devices and our sensors. One of the ways I did this is just a handy thing. If anyone wants to talk to me about it, you can. There's this thing where we had to talk to Bluetooth devices. You had to store things in storage because you're persisting some things temporarily. You had to use network APIs to talk to a service because you're coordinating between some device and some service. Building a UI and being like, that doesn't feel quite right. So I'm going to move something, then rerun the app, then re-log in, then reconnect to a real physical device. You know, it just sucks. So what I did is I built what I called demo mode, our demo service layer. Everything's encapsulated through what I call service layers. And I have a demo data service, a demo device service, a demo network service, and then I have production versions of those. And so inside, I actually switch between demo and production mode. But what's neat is it automatically creates a demo mode for my app. That wasn't why I did it. I did it so I could really quickly go through the UI. But you know, I log in here and I don't have to actually enter a username or a password. And I've got to select something. I'm actually going to log out here and just show you. You're in demo mode and you log in and you type in the password of fail. It says that you failed. So that way I could test the dialogue to make sure that the failure dialogue worked, which is kind of funny. So I want to retry that. So I'll just log in. You don't have to enter anything. But it's nice, and you notice there's delays because I use Event Machine like. I actually don't use Bubble Wrap anymore. But you know, I use basically the timer. So I've got all these timers running to give me seemingly network latency. So I go in and I want to do a new shipment. Now on the device you would see this. You click use barcode and that whole upper block turns into a barcode scanner. So you can scan the barcodes. Nice, it's built in now. You can set various things, labels. You're just pulling these labels from the server so there's a delay. I can then say I want to add a container. This is where I'm pairing a sensor and a container. And then it's scanning for the Bluetooth sensors that are around it. So it looks real. I can select the climate. It's fetching the climates from the server. I can select the sensor. And then it actually connects to the sensor. It goes through the states. So this is the sensor saying, I got this, I got this, I got this. And then the UI is being driven from that. This is all the demo sensor service sending back these events. So it looks very real. And yeah, I can start the shipment. Are you sure? Yes. And it lets me do really simulate the app. Another app that I built using the same thing, and this is take this as an irreligious way, but I was building this for somebody specifically who asked me to do this. This is called Linea, which is the Latin for line. I just like to pronounce it as Linea instead of Linea, which may be the right way to say it, but Linea sounds cool. So the idea was I want to be able to go in and look up a verse of the Bible, and the entire Bible is a single line of text. The whole thing. And if you keep going, it'll eventually go all the way back to the beginning and wrap around to Revelation. So it's pretty cool. And you can actually jump chapters and you can jump verses. You can add additional verses. You can say I want to sort by name instead of by book type. So I go in. Yeah. So no one no one shall add or remove from this book lest no. But and then what you can do, which is kind of cool. So the reason we actually did this is when people are going this verse, this verse, this verse, this verse, I want to make it really quick to be able to look that up, look that up, look that up, look that up, and stack them. So I stack all the verses, and here you're actually like just panning to read. This works really well. Somebody's like talking to you, you can just sit there and pan to read and then stop. But you can keep adding these things, and you just stack them. So if you just want to choose the book, it goes right to the beginning. So it's kind of cool. And then you can close them out. You can even use Biblia, which actually just wraps WebKit and the Biblia web service and looks it up. That was for those people who were like, I can't read on a line. So we did that. And they actually sounded like that because they were... But anyway, that's another app that I built, and that's just a personal one. I've built various other things in this. I've built like 5 or 6 apps internally for what we do. So it's really nice that the framework that I built, for this is very flexible for my needs. Now, again, I said this before. I don't know if people would want this. I mean, there may be ideas in here, like you said, of things that I've done that people would benefit from, but I will open source it if people want to. It's just that this is one of those things that I made to scratch my itch, not because, I was necessarily making it for the rest of the world, and so there's no test. But should someone want to contribute those, no. So but I'll do that if folks want to. But if there are any questions, I'll take them. Yes?
Your update bang, how does it know what builder you used?
So the builder itself is stored as an instance variable in it's like a UI button. Has this instance variable in it, which is the builder instance. You jam it inside the button. What's nice is you're not changing the class because you're just setting an instance variable. And then the update method, which is on kernel, goes, does the thing I'm on have one of these instance variables? If so, I can update. If not, it raises an exception.
I just also wanted to say thank you for giving us so many things we might steal.
That's my job. This is how, and by the way, for those that don't want fragmentation, this was started in 2012. So if you can prove that your code committed before that, then that's fine. Otherwise, this is the root of all things. And you're fragmenting from there. No, I'm kidding.
First to invent instead of first to file?
No, actually, we were first to invent and file. No, it's easy. We actually filed patents on everything. So if you use anything, we are going to do that. Yeah.
Could you expand on the whole mixin issue that you ran into? You initially said
yeah. Well, so basically, if you have a UI button instance, so I have an object, just a Ruby object, and I take a module which has a whole bunch of methods, and I can extend that object instance with that module. Effectively, all those become instance methods on that instance of that object, but only that object. What it does is it builds a singleton class, and then that mixin is inserted in the class hierarchy. But because the objects class is no longer UI button, it's like UI button prime or whatever the thing outputs. It's like some bizarre thing. Some things that expect a UI button don't like that. Like, I don't know what this class is that you're doing,
What about reopening class?
Like UI button? That doesn't change anything. You can reopen UI button, but then you're changing UI button for everybody, which I'd highly recommend you do on your apps. But don't build a library that I use to do that, ever. And actually, I think the reason RMQ has I don't know, I mean, you call them stylers, but basically they're classes that wrap, or instances that wrap those things, and so you have nice methods that go through to the real thing below, but don't change the class of the thing below. It's the same reason you guys, I think, probably did that, is you don't want to change the class of the thing below. You want to merely be able to have a really nice interface on top of that. I don't have an interface in the sense of methods. RMQ does, which is great, I think. But I just have the hash syntax, which fit my need. Yep. Anyone else? Yes.
Do you do anything with UI appearance?
No. I can't tonight. No, I haven't. I did stuff with animation. So it's got animation stuff so that you can move things around, stuff like that very simply. But yeah. Anyone else? Yeah.
Have you run any performance issues?
No, this thing's super fast. No, I mean... So, okay, yeah. No, I mean, table views uses the same. Notice I'm not changing anything. So when you go and you build something like a UI table view cell, it's just going to give you back UI table view cell. But you have to use the same idiom that you would use in iOS to do that if you want to reuse table view cells. I don't fix that. I started that. The builder for table, or the helper for table, right now is like 700 lines of code in the helper to try and solve table views the Ruby way. Never finished it. But someday, if I have enough beer, I will finish it. But it was an idea of being able to, because there's different reasons you want to build table views. Sometimes it's like I've got 15 things that I want to show in table view. Sometimes I have an infinite list of things, right? So you have this performance issue. But either way, you want to be able to reuse table cells. And so I don't have a performance issue there because I just use the traditional way that iOS uses to do that, which is reuse table view cells. I had another question. Yeah. No, but you would have to build a different set of builders, which is where I started, which was how Cocoa was on OS 10. But I never actually ported it there, nor Android. The thing is, syntactically, you could do it, but the options would be different, right? So the options hash would be different on Android, but you could have something that followed a similar pattern, and the idea of nav would be different, right? So you would have something different, but you would have the same conception. And I think that you could definitely bring the style stuff over. Styles would be straightforward. But the components and the options that you could pass to those components would be different. Even if you had some that were the same, you would have some differences because you'd want to take advantage of those differences. And the layout stuff would probably be the same because you can do constraint-based layout on Android. So I would probably, if I ported it to Android, I would just build different sets of builders. And that's the way I would do it that way. But yeah. Well, the community may be going in a different direction.
Hey, you heard him. You heard him.
He does what I say. So anybody want anything? Because I'll tell him. So what? No, I'm kidding. All right, that's it. Yeah, thanks.
I also wanted to share a quick anecdote about Rich Kilmer. The REPL was his fault. He said to Laurent, "This is pretty cool. Needs a REPL," and it's true. Laurent did it. So, Rich Kilmer, everybody.